Okay, now let's look at question 4. So for question 4, the diagram below shows graph of g of x, a. So they gave you g, so let me write it there. So g of x equals to a all over x minus 1 minus 2. The first vertical dotted line, that means dotted line like that, it's going to be for the x, that means 1. Then this negative 2 will be down here. So now you already have where dotted lines are. So now they are asking you for the range. So for the range, you just need to know domain and range are defined by those dotted lines. So domain will be, they're not asking for it, but I'm just saying x is not where the vertical is on 1. For the range, y is not dotted line, negative 2. That's why that. Second one, 4.2, determine the value of a. So they just want this a. To find that a, you just need to find one more point. The given point is 0 and negative 5. So where you see x, where you see y, you just put those. And you solve for a. So here, after this, substituting, they multiply by negative 1 everywhere. Here, here, and here. So if you multiply here, get positive 5 here, you're going to get positive a here, you're going to get positive 2, and then you move the 2 that side. You can use whatever method. The marks are on substitution of that point, and also just getting the a. The method of how you get to the a doesn't matter. 4.3, if another function h of x is g of x minus 3, x minus 3 just means you move g to the right, that way. So you take every point, you move it to the right. Then after moving to the right, move it up by 7. Then what will be the point of intersection of the asymptotes, the dotted lines? So let's see. Now, if you have the Cartesian plane, you know this dotted line is on 1. And then we said this is 3 to the right, not left, right. So 3 to the right means 1, 2, 3. So from 2, it's going to be 3, 4, there. That means 1, 2, 3, the dotted line will be on 4 after moving it to the right. So this one will be on 4. So it's not going to be on 1. Now, the one that was on negative 2. Again, I'm using the same graph, but then just drawing dotted lines. The one that is negative 2, when you move it to the right, it's not affected. But when you move it up by 7, it's going to be negative 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. So it's going to be negative 1, 0, 1, 2, 3, 4, 5. So the dotted line will be there now. So the question is asking you, where are the asymptotes going to meet? So they're going to meet there. So the coordinates will be 4, because it's a 4 here. And then it's to 5. It's a 5 here. So you just move the given asymptotes. The x1, you move it to the right by 3, and then you move the horizontal one up by 7. So you can just use the first solution. That is, you know the original one was this. So on the 1, you're going to add 3. So you're going to say plus 3. On the second one, you get the one that you move up, just get plus 7. Then you're going to get 4 and 5. Otherwise, I believe you should get the whole marks if you just do it the way we did it with the sketch here. You should get all the marks. Question 5. For question 5, it says they gave you an equation. So the equation, first given the equation, f of x equals to 1 over 4 all to exponent x. First one, determine the value f of negative 2. That is if x is negative 2. So you put negative 2 there. That's why there gets 16. Now, I think that's important going down. So if x, we write it as a coordinate. So it's basically saying if x is negative 2, your y is 16. That is for f of x. Second question. Write down the equation of the inverse in the form. Okay, this one is the one where you have to change. Remember, f of x is 1 over 4, 6 exponent x. Change this to y. So the f of x, put it as y. Swap x and y for the inverse. There, that's a mark for interchanging the x and y. And then use logs. Log says this is equals to the log. Here at the bottom you put whatever is here. So it's 1/4. And then on the other side you put the x. And that's how you get this. Now this one, what they did was, after, if you want to get this one, you're not supposed to get both. One is fine. If you want to get that one, after doing this, you say x equals to the 1/4, you put it as 4 to expand negative y. Then you use logs. So logs will be negative y equals to negative y equals to log of base of 4, and then x, then you divide by negative, you're going to get that. 5.3. 5.3 says Enru has no idea on how to draw the graph of the inverse of f. Explain to Enru how he may use the graph of f to draw the graph of inverse of f. So the solutions, again, this is just saying, okay, if you have the original graph, how can you draw the inverse? Here, the basic thing that you just have to say is you just swap x and y. If you have the coordinates for the f, you just swap x and y with those coordinates, and then you use them to draw the inverse. That's basically it. As you can see, swap x and y gives you the mark that they give. Otherwise, you may say the x and the y coordinates of f may be swapped around to obtain the coordinates of the inverse of f. That's basically enough. 5.4, hence or otherwise sketch the graph of the inverse of f. For the f, again, on the first one, we already found one coordinate. The other coordinate is if you have x as x as 1. X is or for the original, x is 0. So for f of x, not the inverse, f of x, we found that if, from the first question, if x is -2, y is 16. Again, for f of x, not the inverse, the original. If x is 0, you can plug in 0 then see. If you put 0 here, what do you get? You get the 1. So you can use that point or use another point if you want to, but then it always passes there on 1 and 0 and 0 and 1. So you can always use 0 and 1. So that's the original. That means for the inverse, according to how we said on 5.3, you can just swap the points. That means you want to have 16 and -2, 1 and 0. So you just have to plot those points. So the first, this one, going to be here, there. That's 1 is to 0. And then the other point is 16. You just move them away from here. The other point will be 16 and -2. So the x is 16, and then let's say -2 there. Let's say this is our -2. So the other point will be there. Then you just join them. Now remember, there'll be a dotted line on top of the y-axis. Basically, you can't touch the y-axis. Remember not to touch the y-axis. And that'll be your curve. Next question is 5.5. Write down the domain of f. The domain of f, you may just use the sketch that you have. Domain is the axis, so you can see they exist after here. It doesn't touch the y-axis, and then it goes that way. That way it exists. So that means x is bigger than 0. 5.6. For which values of x will the inverse of f be greater or equal to -2? You can again just use the sketch. So let's see, where's f? Remember this, it just means where's the graph above -2. So let's draw the -2 line and then find the x's. So we already drew it here. So the -2 line is here. So this is the inverse, this is the -2 line. Remember, we want where the inverse is above -2. So it's above here. Up until up there. So from here, the x is 16. Then all of this x is the x up until 0 here, without including the 0. That means x is between 16, including the 16, because here it's also on top. Equals means also on top. and then 0. On 0, it doesn't touch the 0. Remember, it doesn't touch the y-axis. It just gets slow. That's why the answer is that. You can use another notation of the same thing. For the same thing, you can use that notation as well. 5.7. 5.7 says given Q. So they say Q equals to log of 1 over 4, 1 over 2. Find Q. You can just take your calculator, press it, get 1 over 2. The other, I'm not going to entertain the other ways. Just press your calculator and get the answer.